In this video, let's see how to install the data plane on Azure. The steps to install data plane on Azure include the initial setup in ADOC, uploading the YAML file to the Azure container, and filling in the deployment details. To start off, you'll first have to sign in and pick a database. I'm picking Snowflake, and you'll have to enter the data source's name. The description is optional, and then you can enable data reliability, compute observability, or both, and then click Setup Data Plane. Now in the Setup Data Plane page, you'll have to enter the data plane name, give it a description, then enter the external IP address of the data plane installation. Choose a cloud provider, we'll be choosing Azure. Enter the data reliability result location and data plane results path. For the data plane Spark configurations, we'll be choosing Kubernetes as the processor type. You can leave the configurations as is or change and then click submit. As you can see, a YAML file is downloaded onto your computer and a pop-up is displayed with instructions to go further. As the instructions suggest, we'll have to place the YAML file in our Azure Data Lake. To do so, you'll have to navigate to the Microsoft Azure portal and select your default resource group. In the resource group, there'll be a data plane storage account. You'll have to select it and then upload the file that was downloaded previously into the storage account. You can either select an existing container or a new container. As you can see, the file has been successfully uploaded into the container. You can go to containers from here, and this is the new container where the file has been uploaded. Now that the YAML file has been uploaded, let's go back to the Axle Data UI and click on Proceed. Now this will redirect us to the Azure Data Plane setup configuration template. This is the Azure resource template which has to be filled up in order to deploy the data plane into your environment. You can either create a new resource group or select an already existing one. In this example, we'll be selecting an already existing resource group. You'll have to provide an AKS cluster name. Next, for the virtual network create field, you can either create a new virtual network or use an existing one. And for availability zones, you can enter the number of zones required for the setup of your data plane. For this demo, we'll just be entering a single availability zone. Because we have set the virtual network create field to true, the custom deployment template will deploy everything on its own. For example, virtual network and subnet creation will occur on their own, so we can proceed in this manner. Depending on the complexity and size of data, you can go ahead and choose the agent VM size. The Kubernetes cluster in regard to this template will have a minimum, maximum, and desired number of node count. This is the minimum node count, this is the maximum node count, and we're choosing 2 as our desired node count. By default, the disk space provided is 30 GB, but you can change the value according to your needs. In this case, we don't need to add the VNet resource group name, the VNet name, and the subnet name since we have selected true as our option for the virtual network create field. Control plane SKU will be choosing the paid version, and for admin groups as well as IP whitelist, we'll be leaving the default values as is. You can either choose private cluster or public cluster. I'll be choosing public cluster, so private cluster will be set to false. Managed identity name is a role name which is created in the backend. It connects the deployment strips to the Kubernetes cluster. You can give any custom role name for this field. For this field, if you're using a dev account, you can add -dev. Since we removed the dev, now this becomes a production bucket, which will have a Helm chart and deployment strips. But we are going to go ahead as a dev account, so we'll add back the -dev. Now we'll have to add the location of the YAML file. Since I've already added the file to the container, I'll have to go to the resource group, then to the storage account, navigate to the container, and copy the path of the YAML file and paste it in the respective field. For the storage account name, we will have to go back to the Azure portal and check. The storage account name in this demo is dataplane client values. The storage container name by default is new container, but the storage container name as well as the storage account name can be changed. For storage access key, in the storage account on the left navigation, there is an option called access keys. You can copy and paste this key in the respective field. This will allow the deployment scripts to clone the YAML file and apply the Helm chart accordingly. The internal level configurations like Spark driver memory, Spark driver cores, Spark executor memory, etc. can either be left at their default values or changed as per the need. Since all the fields are filled, let's click on Review and Create. The validation test has passed, so let's click on Create. It will take around 7 to 8 minutes to spin up all the resources in this template. Now that the deployment is complete, we can examine the resources that were spun up during the deployment. So the dataplane init container is one of the main resources used to debug the deployment. We can click on it, then select containers from the left navigation bar, and then logs from the page that appears. This allows you to view the deployed containers logs as well as the scripts that are responsible for deploying each and every resource of our Helm and Kubernetes configurations that are required on the dataplane side. The deployment of all resources takes time, but you can check the progress by refreshing. We can now return to our application's data plane and select a data source. Let's call it Azure. Let's enable compute observability and data reliability. And now we can see that there is an option in the Select Data Plane dropdown, which indicates that the data plane installation on Azure was successful. We must select the option and then click Next. Enter the Snowflake connection details, which include Snowflake URL, username, password, and role, and then click the Test Connection button. Once the connection is established, we can proceed. You must then choose a warehouse for compute observability and data reliability, as well as a database for data reliability, enable query analysis, and finally click Submit. Now navigate to data sources. As you can see, our data source has been displayed on this page. We can run the crawler to get information about all of the tables. We'll have to wait until the crawl is finished before viewing the table information in the data reliability section. We also have a mechanism in place within the Azure container to check the current state of our data plane. To see the results, run this code. And this is how we install data plane on Azure. Thank you for watching.